Hi everyone. In the previous video we have completed the pre-layout simulation of RS Latch. Now we are going to design layout, and after the completion of the layout design we are going to check the results of layout design and comparison of both pre-layout and post-layout simulation results and finding the parasitic difference between the post-layout and pre-layout simulation results. So go to launch, select layout Excel and press OK, and view on type must be layout, press OK. Window will open here. Maximize the screen and press F to fit the screen and go to connectivity, generate all from the source. Use chaining option and the minimum separation I am taking as 0.12 and place the components in boundary and go to IO pins and draw the layers as metal 1. Select apply and press OK. Press Shift F to see the source and drains in transistors. Press S to stretch the boundaries. I am creating substrate to every PMOS and NMOS. I am first creating the substrate to the PMOS. Select the transistor and press Q. Maximize the screen and go to parameter, body type, detach. For PMOS, keep it as top tab. Like this, I am creating substrate to all transistors. For NMOS, select the substrate as bottom tab. Now go to Window, Assistance and Navigator. Turn on the Navigator. Navigator will show the connections between the poly. When we have using the chaining option, by default net 36 and net 39 are connected. So to connect Q, we need to connect these two and these two, and we should join to this metal pin. I am extending the boundary. First I am connecting the VDD connection. To connect the VDD connection, we need to connect this transistor, PMOS transistor to substrate and the VDD pin to the substrate. So Select metal 1 drawing and press P for the metal path. First I connected the PMOS transistor to this substrate. I have completed the VDD connection. Then after go to VSS. For VSS connection, we need to connect these 3 transistors to the substrate and then this metal to this above connection. So plus P. We have completed the VSS connection also. Then go to Q and we have 4 connections are remaining: Q, QB, R and S. So first I am connecting the QB. We need to join these 2 metals and these 2 poly, and we need to join the poly and metal, and afterwards we need to join to this pin. Now I am going to do the connections for first I am doing the connections for QB. I am going to join these 2 using the metal. So selecting the path P, press F for fit. I'm increasing, I'm going in this way because I'm creating somewhat more space. By increasing space, we can use via, so the overlap of poly to poly and metal to metal will not come if we create more space. So I need to join this poly to this poly. So I am using the poly layer. Press P. Enter. And then we need to join both these 2. So I'm placing an wire. I will place the wire here. I'm joining one side poly. Another side I am joining the metal. After that, we need to connect with this pin. So we have connected the connection of the QB. Next, we are going to connect the connection of Q. So to connect the Q, we need to join this poly to poly and this metal to metal. For joining the poly to poly, I am choosing the poly layer. Press P to get the path. Fit. We need to join this to metal also. Using the I am creating some word space. So to avoid the overlap of the poly to poly and also metal to metal, we need to connect these two. There is another connection. See, if we join this poly to poly, the distance between these two polys will be less than 0.7 micrometer. So there will be a design rule check error. So I am deleting this poly. Now we are going to connect these two. We need to join this poly and this metal. So I am using via. I am keeping the wire here. First I am joining the poly. And then metal. Now we need to join output pin to this metal. We have completed the connection of Q and then QB also. Now we need to join R and S. So first I am selecting the R. We need to join both of these two. So I am using poly. Press P. center. Now we need to join this metal pin to this poly. So directly we cannot join. Now we need to connect this metal pin to this poly. I am using wire. I am placing one wire here and another wire also here. So I am joining the poly. Sorry. I'm placing another wire also here. I joined this both using poly. Now we have completed the connection of R also. Now we are going to connect S. We need to join both these using poly layers. I select P. We cannot directly join the metal and poly, so I'm using wire. First I'm joining the poly side. Now select metal. Now we have completed all the connections. Now we are going to check if there are any errors in this design. So run DRC. DRC means design rule check. That's okay. Yes. There are no errors found. So go to Asura and run LUS. These are all default options. Layout and schematic are matched. Then Asura, go to layout design, Asura, run RCX. RCX completed successfully. Now go to Virtuoso window, tools, library manager, select VLSI lab, rs/db and create a config file. To create a file, go to new cell view and in cell view keep the type as config and press OK. The view as schematic, you go to use template and keep the template name as Spectre and press OK. Just save and open and we get our test bench window. Press F to fit and go to launch and simulate. Choose transient analysis and keep the stop time as 200 nanoseconds and accuracy defaults as moderate. Go to outputs, plot to be plotted. First select the and simulate. We are getting the previous results and then go to the config window. Now select the schematic, right click, set cell view and set it as AV extracted. Just save and open again and we'll get the same test bench window. Now here in place of replace, keep append and simulate. See, these are pre-layout simulation results and these are post-layout simulation results. In order to see the parasitic difference between the pre-layout and post-layout simulations, place R in pre-layout simulation and R in post-layout simulation. Overlap all these same type of components and just move the cursor and see the parasitic difference between these two. Change these names of this Q underscore SCH and this as layout. This is the parasitic difference between. We can change the colors by trace properties. Blue.